So today we are going to see one more scenario and as the title says Kubernetes deployment update and rollback real world DevOps scenario. So let's see the scenario in detail. There is the production deployment plan for the next week. DevOps team want to test the deployment update and rollback on the dev environment first that they can identify the risks in advance. Below you can find the more detail about the plan they want to execute. Create a namespace data center, create a deployment called the HTTP deploy under the same namespace. It should have one container called HTTPD. Use the image this one has the three replica. The deployment use the rolling update strategy with max surge equal to 1 and max unavailable equal to 2. Also create a node port service, name the HTTP service, expose the deployment on the node port 3008. Now upgrade the deployment to versions this one using the rolling update. Finally, once all the ports are updated, undo the recent update and roll back to the previous or original version. So in short, we have the deployment. We are going to upgrade to the newer version of the image. Then after the upgrade, we are going to roll back to the previous version. So what we are going to achieve, let's see first that one. So if you see in the conclusion, learn how to certify and test the SKU deployment, update and rollback in the Kubernetes using the real world DevOps scenario. In this hands-on tutorial, we shall walk through creating a dedicated namespace for testing, deploying a HTTP application with the rolling update strategy, exposing a deployment via the node port service, performing a versions upgrade using the kubelet set image, rolling back to the previous version without breaking the revision history. Okay, so now let's see the our YAML file and all the step how we are going to update our image in the production and then we are going to roll back to the previous. So first step is to create the namespace. Namespace we can create in the two way, either by using the kubectl command or YAML file also. So here we have created by the help of kubectl create namespace and the namespace name data center namespace is created. Now let's see the YAML file of the deployment and node port services. So first YAML file of the deployment, we have API version of the deployment app v1, kind is the deployment, metadata, name of the deployment is HTTP deploy, the that namespace in which the deployment is going to deploy is the data center. In the spec replica we have the three and this is the rolling upgrade strategy. Type is rolling updates, rolling update, max surge is 1, max unavailable is 2. We will be describe this one later. Selector we have match label app equal to HTTP template metadata we are going to match the pod with this label only, and specs container name we have the HTTPD and image we have the 2428 port, container port we have 80, and let's see the YAML file of the service. API version of the service is v1, kind of the service is service, and metadata name of the service is HTTP service, namespace in which service is going to deploy is the data center, specs this service is node port type. Selectors we have the app equal to HTTP. By the help of this selector only it's going to match with the pod, and port service port we have the 80, target port means container port we have 80, and node port we have 3008. After that we are going to apply this YAML file. So you can see the deployment is created, service is created. Then if you describe this deployment, then we are able to see this is the image we have in current deployment. Then we are going to update with the new image which we get from the development team after some changes. So we can set the kubectl set image deployment and deployment name, then http container name and with a new image and hyphen n data center means namespace. So by the help of this we can update our image. So you can see the image is updated. Now if you describe the our latest image is updated. Previously we have the 2428, now we have 2443. So you can confirm the same thing by using the kubectl rollout status and the name of the deployment, then namespace. You can see our deployment successfully rollout and rolling to the previous version. Now after the successfully deployed to the newer version, now if you want to roll out means back to our previous versions, we can simply run the command kubectl rollout and undo deployment and deployment name and hyphen and data center. Then we can see our deployment is rollback. Same thing we can confirm by kubectl describe, and if we grab the image then we got the previous 2428. So previously we have the 2428 only, then we got the 28. Same thing we can see the history, what all the changes are happen. Now let's see the detail in our rolling update strategy, where the rolling update max surge equal to 1 and max unavailable equal to 2. What all this meaning is there? So type equal to rolling update. This tell the Kubernetes to use the rolling update strategy, which means pod are updated gradually, not all at once. It ensures highly availability during the update. All pod are terminated only after new pod are up and running. It means once the new pod will be run, then only old pod are going to terminated. Now let's see the rolling update parameter. Max surge equal to 1. This defines the maximum number of extra pods that can be created above the desired number of the replica during the update. In your case, deployment has the 3 replicas, so during the update, the Kubernetes can temporarily run up to the 4 pod, 3 existing plus 1 new. This helps speed up the update while maintaining the availability. And second parameter max unavailable equal to this define the maximum number of pods that can be unavailable during the update. In your case, up to two pods can be taken down at the time while new one are being created. This allows the Kubernetes replace pod faster, but it also means only one pod will be serving the traffic during the update. How it work? Let's say you are updating from this to this. Kubernetes start by creating one new pod due to max surge equal to 1. It then terminate up to the two old pod due to the max unavailable equal to 2. This cycle continue until all the pod are replaced with the new one. At any point there will be at least one pod running, ensuring the minimum downtime. Why this matter? Max surge help maintaining the availability by adding the new pods before removing the old one. Max unavailable control how many pods can be offline, balancing a speed and reliability. This strategy is ideal for critical services where the downtime preferred for the fast rollout and also needed. So in short, all the step whatever given in the block is we are trying to deploy our application into the productions. After that, if someday after some day development team want to provide the new image, they have done changes, then we are going to apply those image in our production cluster. But applying into the production cluster we found that there is some bug, then again we are going to roll back to our previous version. So how we are going to see? Let's see. So same, let's copy the YAML file, and same thing I have copied here in our notepad. So let's copy it. Now let's go to our production clusters. So this is our production cluster. Create one file. let's say the pod.yml. Now save it. Now apply it. kubectl apply hyphen f pod.yml. Okay, so before applying, we need to create the namespace. So let's first create the namespace. kubectl create namespace. So namespace is created. Now let's again apply it. So now we can see the deployment is created. Our service is created. Same thing we can confirm by kubectl get all hyphen n paste the namespace. So we can see the three pod are running, service are there, deployment are there, replica set is there. Now let's see the current version of the image what we have. So we can see by the help of this kubectl describe command. Let's copy and paste. So kubectl describe deploy, the deployment name hyphen n namespace grep image. So current two versions of image we have 3428. Now let's go to the next step. Now let's say the now upgrade the image to the newer versions. So we are going to upgrade by the help of kubectl set image deployment, then deployment name, then we have the container name and image name, and then hyphen n, the namespace name. So now our deployment is updated. Now let's see the image now. So you can see now the image is upgraded to port 43. Previously we have to port 28. Now our next step is to roll out a status. If you want to check the whether the rollout is completed successful or not, then we can run this command. So here showing the rollout successfully. Now next step is to the, now suppose after the new version of image deployment, people reported some bug, then we need to change to the previous version. So how we are going to do the changes to the previous version? This is the command. Just copied it, then paste it, kubectl rollout undo deployment, and then deployment name, then hyphen n data center. So we can see the our rollout is successful. Now let's see the image. What is the image? So we can see we have back to our previous image 2428. Previously we have to the 2428. Now let's see the next. If you want to see the rollout history, then you can run this command also. So paste it. Let's. So it will be give the all the rollout history. So in this way we can upgrade the our image in the production, and if people report some bug, then we can roll back to the our previous versions. All the command and all the step are given in the our blog, and blog link I'll be attached into the resource part of this video. Thank you. Happy learning.